done before, but we're going to do it again. Over here, a pretty funny picture of this guy skiing down a escalator. I'm not big into skiing, but this might be a different way to do it, except it looks absolutely terrifying to me, so I probably would never do that either. So slope again, this is nothing you haven't seen before, all right? I'm going to teach it to you like you've seen it before. I'm sorry. You should know how to do this, and I'm going to make it quick. So slope is denoted by the letter M. It's a non-vertical line is the ratio of the vertical change, the rise, to the horizontal change, the run. All right? So if I have 2 points, it's how much does it go up, the rise, or the difference in my two vertical components, and over the run, the difference between my two x's or horizontal components. So you can see here's the big formula, y2 minus y1 over x2 minus x1, and again it's rise over run. We've done this a bunch, but you know, it is what it is, right? So let's take a look. Alright, so find the slope for each, then tell whether it rises, falls, is horizontal or vertical. So without using graphs, you should be able to tell a lot of information from the slope, and that's the point where some of you need to get better. So let's do our little formula. I'll write it here. y2 minus y1 over x2 minus x1. Remember, these are x's and then y's, x's and then y's. Typically, these are going to be the first point, so x1 and y1, and this is the second point, x2 and y2. Really doesn't make a difference. You'll get the same answer, all right? So negative 4 minus 5, y2 minus y1, over negative 2 minus 4, x2 minus x1. That gives me negative 4 minus 5 is negative 9. Negative 2 minus 4 is negative 6. And of course, with slope, you want to reduce, and we like fractions with slope. So we're going to have 3 over 2. All right, so that is a slope. Now let's talk about that. That's a positive number, right? So it's a positive slope. So when you think positive, you need to understand that as it goes to the right, if I have my x and y axis, as I go to the right, it rises. All right, it would rise. So positive would always rise because it'd be like this, up 3 over 2, up 3 over 2. It's always going to rise, no matter what kind of positive number it is. All right, let's try the next one. y2 minus y1, 3 minus 5, over x2, 10 minus x1, 4. 3 minus 5 is negative 2, 10 minus 4 is 6, and that reduces to negative 1/3. All right, so that's a negative number, right? So we need to understand that negative is the opposite of positive. So these are all going to not rise, but these are all going to fall. So this one falls. Let's take a look why. If I'm anywhere, let's say I'm right here, if I go down 1 and over 3, down 1 and over 3, it's going to look like that. It's going to fall as I go to the right. Down 1 and over 3. It doesn't matter which this is. Remember, that's very important. That negative is either negative 1 over positive 3, we can write it like that. Positive 1 over negative 3, we can write it like that. Or most of the time, we just write it out into the front. This front does not make both negative. If we're both negative, that would make it a positive, because a negative divided by a negative is a positive. You need to remember that. It's one of the things that really is a pet peeve of mine, seeing kids still make that mistake, and you shouldn't make that mistake by now. All right? So let's take a look over here. Try this one. y2 is 10 minus y1 is 8. x2 is 4 minus x1 is 4. 10 minus 2 is 10 minus 8 is 2. 4 minus 4 is 0. I'm not allowed to divide by 0. There's no groups of 0 and 2, so remember that is undefined. All right, now let's take a look on our graph what kind of line that is. There's a change of 2, so let's just say I start here. I go up 2, but I go over none. I go up 2, I don't go over. So these are vertical lines. All right, so vertical lines, anytime you have an undefined slope, you need to know that it is a vertical line. All right, that's the part that I think you guys need to understand better. Okay, you can get the slope, but you understand it always is going to go up and to the right. If it's a negative, is it always going to go down and to the right? If it's undefined, it's always vertical. I wonder what this one's going to be. Negative 2 minus negative 2 over negative 3 minus 6. Negative 2 minus negative, that's 0 over negative 9, which is 0. So let's take a look at our graph. Say I start here. If I go up and down 0, but over 9, that's a horizontal line. Alright? So anytime you have a slope of 0, it's going to be horizontal. Alright? Good. Alright, now we have two kinds of special cases with lines. We have parallel lines and lines that are parallel if and only if they have the same exact slope. Take a look right here. If I have my coordinate plane and we know parallel lines never touch. And the reason being is I go up 2 on this one and 3 over. I go up 2 on this one and 3 over. They're never going to cross. So if you ever have two lines and the slopes are the same, they are parallel. Perpendicular lines. Lines are perpendicular if and only if their slopes are negative reciprocals of each other. That means I can take the slope of the first, multiply it by the slope of the second, and it gets negative 1. Alright? Now, that's what you need to understand. A negative reciprocal looks like this. 1 over 4, the reciprocal, I flip it, 4 over 1. If 1 over 4 is positive, then this has to be negative. Those are negative reciprocals. If, say, I had negative 2/3, the negative reciprocal of negative 2/3 would be, flip it, 3/2, and negative would become a positive. Alright? So that's perpendicular. If you see that, it's perpendicular. If you see this situation where it's like 4/5 is one slope and 5/4 is the other slope, that's absolutely nothing. They're not perpendicular, they're not parallel, they're going to cross, but nothing fancy. Alright? Alright, so let's do some. Are the following parallel, perpendicular, neither? So we have line 1, so I have to find slope 1 here. Negative 1 minus 2. 0 minus negative 2. Negative 1 minus 2 is negative 3 over 2. Alright, let's find slope 2. 3 minus negative 1. And then 2 minus negative 4. 3 minus negative 1 is 4. 2 minus negative 4 is 6. So if I look at this right now, it doesn't look like anything very good at all. Of course, I need to reduce. 4/6 is the same as 2/3. Now I can see the relationship. These are negative reciprocals, therefore they are perpendicular. And sometimes you'll see me write shorthand for perpendicular as an upside down T. Alright? Alright, let's take a look at this one. Find the slope of the first line. Negative 3 minus 2. 4 minus 1. So negative 3 minus 2 is negative 5. 4 minus 1 is 3. Find the next one. Negative 2 minus 3. And negative 1 minus negative 4. Alright, so negative 2 minus 3 is negative 5. Negative 1 minus negative 4 is positive 3. They're exactly the same. Therefore, the lines are parallel. And shorthand for parallel, two lines running right next to each other like train tracks that are never going to hit. Parallel. Alright, rate of change. Rate of change is slope that represents how much one quantity changes on average relative to the change in another quantity. And the units are important. Basically, it's the exact same thing as slope. We're going to find 2 points, and we're going to calculate the slope. We're going to label it a little bit differently, and we may not use fractions in this because they're real-world situations, and a lot of times you don't see like 2/3 miles per gallon. All right, but so we'll probably do decimals, but otherwise it's just slope. All right, so let's look at the problem here. We got, whoa, where are you going? All right, just X this out. All right, so here we go. So what's the rate of change in the diameter over time of this tree? So in 1965, it was 137. In 2005, it's 141 inches. So let's take a look here. So we have two things. We have time and we have inches. Now the question is, which is x and which is y? And it'll tell you what's the rate of change in diameter over time, or per. So time's going to be on the bottom, and what's the bottom? X. So this is going to be y and x. So this is essentially just the point 1965, comma 137. This is the point 2005, comma 141. All right, then we can do our formula. 141 minus 137 over 2005 minus 1965. And we will get 0.1. Now I could have had that as 1/10, but this is rate of change. So 0.1, and then the units are important. What's on top? All right, inches. So 0.1 inches per year. All right, I don't put inches over year. I want that word per is pretty important. Predict the diameter in 2065. Well, right now in 2005, it's 141. And on average, it's going to grow 0.1 inches, right? And how many years? From 2005 to 2065, that's 60 years. So 60 times 0.1 is 6. 141 plus 6 is 147 inches. All right? It's not growing real fast, is it? All right, so let's look down here. A car uses 3 gallons of gas for 50 miles on one trip and uses 9 gallons of gas for 140 miles on another. What's the average rate of change in miles per gallon? Miles per gallon. Miles is on top. That means it's a Y. Gallons on bottom. That means it's an X. So 350 is 1 point. 140 is the other point. So we have 140 minus 50 divided by 9 minus 3. Right? We get 90 divided by 6, which is, I believe, 15. And the units are important here. If you don't have the units, it's not right. Miles per gallon. All right? All right, so pause the video right there. I want you to take a second and try these two. All right, welcome back. Let's see what we got. So we need to find the line, the slope of the first line. So that's 0.2 minus 3.2 over negative 2.5 minus 4.5. So we get negative 3 on top and negative 7 on the bottom, which is positive 3 over 7. Let's find the slope of the second one. That's 0 minus 3 on top, 10 minus 3 on the bottom. That's negative 3 over 7. Negative 3 over 7 and 3 over 7, they're not equal, and they're not negative reciprocals, so this is neither parallel or perpendicular. All right, after 2 months, a bamboo plant was 1.7 inches tall. After 8 months, it was 12.4 inches tall. Find the rate of change in terms of inches per month. So inches per month. Inches means that's the Y. Months, there we go. So 2 comma 1.75. And then we had, what's the other one? 8 and 12.4. So 12.4 minus 1.75 over 8 minus 2. Whoops. That's an easy one on the bottom. That's 6. On top, that's 10.65. And then divide those, and I think you're going to get 1.775 inches per month. All right, there you have it. I'll end with a little silly video on hopefully helps you remember slope if you don't already remember it. Otherwise, I'll catch you on the flip side later.
Math equation, slope, 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 the slope formula stop. Hey, math equation, slope, 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 slope formula stop. There is a formula you can use to find the slope, which is usually represented by letter M. This is no joke. The slope of a line is the difference of the y's over difference of the x's. You take a point, label it X1 and Y1. Take a second point, label it X2 and Y2. Then subtract the 2. The Y's will give you the rise, the X's give you the run. This is called a slope. The slope formula is super easy. It helps you find rise over run. The slope formula is super easy. When it's done, it can be fun. X2 minus X1 is the run, 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 run. The slope formula style. Formula style. Slope, 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 slope. The slope formula style. Slope, 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 slope. The slope formula style. Slope, 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 slope. The slope formula style.